Let's go in the other direction for this ellipse. Rather than having the equation and graphing it, let's give a few pieces of information and see if we can figure out the graph and the equation. So here it says an ellipse has a horizontal minor axis. You have to tell which direction it's going in, otherwise you would have no clue. And the length of it is 3. And a focal length, and what I mean by focal length is from the center to the focus, of 4. This ellipse is centered at -4, 5, all right? And we want to find the equation of the ellipse. So if the center of the ellipse is -4, +5, then this ellipse would be here. Now we have to be a little bit cautious here. The ellipse has a horizontal minor axis of length of 3. So when we're talking about that, it's going to be horizontal, so it'll be going this direction. But a lot of people, when they see that 3, they go 1, 2, 3. And if you did that, you'd also have to go 3 the other direction because this is the center. But that would be a minor axis length of 6. So when we want 3, we have to go 1.5 to the right and 1.5 to the left. So this is our minor axis going through the center. That means our major axis is going the other direction. So the major axis has to be going this way. And it's going to be longer, so I'm just going to put arrows here to designate that it goes along this line someplace. All right, so when we talk about the focal length from center to focus is 4, then we have to start at the center here and move along the major axis, which is this along this green line. So we're going to go 1, 2, 3, 4 down, and then of course 4 up would be someplace up here. Okay, so we can graph this thing. You know, it would look something like this. And we get a pretty picture, except for one problem. That's not the graph of it. When we drew those 2 points, those were the foci. So it'd probably be best if you labeled them. Let's call this one foci 2 since he's lower, and let's call this one up here foci 1. All right, so these are just the foci. These have nothing to do with the major axis, and they're not the end of the ellipse. All right, so what do we know? We know a few things about this picture. Purple. This distance is c, because it's the distance from the center of the ellipse to the foci, so that's c. This distance along the minor axis, that has to be b. So what's missing is the a. All right, so we're going to set up our little equation, make it a little thinner. C squared is equal to the bigger number, a squared, minus the smaller number, b squared. So we know what c is equal to. C is equal to 4. So this is going to be 4 squared. We don't know what a is equal to, so I'll leave that as a squared. And we know b is equal to 1.5. Now remember, this wasn't 2, this was half of 3, so it's 1.5. So we're going to get 3 halves. I'll leave it as a fraction. You can put 1.5 also. But don't forget to, well, square it. So what we're trying to solve for is, what is a equal to? All right, so 3 halves squared is 9/4, and we're going to add that over. So we're going to get 16 plus 9/4 is equal to a squared. 4 times 16, I'm quite sure that's 64. Yeah, so we're going to get 64/4 plus 9/4. So 64/4 plus 9/4. I do it in my head, but I know I would make a mistake. So that would be 73/4. So a is going to equal, I'm sorry, a squared is going to equal 73/4. And then little a, just a itself, is going to equal the square root of that. So it would be square root of 73 over 2. Let's see what that is decimally. So square root of 73, don't forget to close the parentheses, divide by 2. So that's approximately 4.3. So it's just a little lower than these foci. So we're talking about a little bit down here and a little bit up there. And then this would become your ellipse with the foci on the inside of it along the major axis. All right, so now for the equation. The equation is x minus h. I use the circle designation over something, and I'll leave that alone for a second. This is going to be y minus k all squared over something as equal to 1. Now, in this case, since the a is the bigger number and it's going vertically, it has to go underneath y. So this is going to be your a squared. Therefore, this one is going to be b squared. So to plug in all the information, we now get x minus, back to our center here, of negative 4, 5. So it would be x minus a negative 4, so that would be x plus 4 all squared. B was equal to 3 halves. So, I'm sorry, b squared is what needs to go down here, so that's that 9 fourths. So we're going to put 9 fourths. Now, you can put 9 fourths in the bottom. It'll look a little funny, but we can fix it in a little bit. Plus, all right, and then y minus k is going to be y minus that 5, the center, all squared, over a squared, and a squared was 73 fourths. So 73 fourths, and it's equal to 1. So that's a decent equation. It just looks a little funny. I hate having fractions inside of fractions. So the last step is actually cleaning it up. It doesn't help you graph it, but it just makes it look a little prettier. We're going to reciprocate this. In other words, when you divide a fraction by a fraction, you can flip and multiply. So this is going to become much neater. 4 times x plus 4 all squared over 9. Let's get this out of the way. Plus, and then the same thing, reciprocate here, and you're going to get 4 times y minus 5 all squared over 73, and this thing is equal to 1. So this would be the equation of the ellipse that has these properties or this information.